Okay, so we are going to go ahead and do the second part of the test review for our final. It starts with completing the square, and completing the square always starts by removing any constants from the left side of the equal sign. So I'm going to add the 32 to get it out of the way. Gives me x squared plus 16x. I'm going to write plus blank equals 32 plus blank. I need to fill in that perfect square number. The way we find it is always by taking half of this x term, which is half of 16 is 8, and squaring that number. So I'm going to go ahead and add 64 to both sides. This side here on the left should now factor as x plus 8 times x plus 8 equals 96. Now this becomes x plus 8 quantity squared equals 96, and here's where I'm going to take a square root so that x plus 8 equals plus or minus the square root of 96. Now 96, if we think about how it's created or what multiplies to make that 96, we might realize that 96 divides by 16, and it does that 6 times. So I can have a root 16 and a root 6. Now the square root of 16 is 4, so I'm going to have a 4 root 6. To solve for x completely, I need to minus this 8, meaning that my final answer would be x equals negative 8 plus or minus 4 root 6. Alright, now number 18, we're solving for the absolute value. When we solve an absolute value, we need to deal with the fact that the inside of the absolute value could turn out positive or negative. And so we're going to take 3x plus 7, set it greater than or equal to 8, or 3x plus 7. Now when I switch the 8 to a negative 8, I have to flip the sign from a greater than to a less than equal to. So now I'm going to solve both of these the same way. Minus 7 in both cases. I get 3x is greater than or equal to 1, or 3x is less than or equal to negative 15. Dividing by 3 in every case. X is greater than or equal to 1/3, or x is less than or equal to negative 5. Now this is an acceptable way to put it. Depending on the multiple choice, you might have it written that way. You might also have it written in a graph. It could be done by graph. If that's 0, here's 1/3, and way over here is negative 5. Because they're equal to bars, they'd be solid dots, or possibly a bracket. Those are the two choices. So you could see a bracket, or you could see a solid dot, and then they would point off to the edges. Because x is bigger than 1/3, that's to the right, x is less than, or to the left of negative 5. The last way you might see this is an interval notation, which is really nice because it works from left to right. The farthest to the left that I'm shading is negative infinity. Whoops. And I'm going to come out to negative 5. Now this is important. Because of the equal to bar, this is not a parentheses, but a square bracket. Same thing with this 1/3 here. Because it's included with a solid dot, we're going to use a bracket, and that's going to go on forever to infinity. Alright. Number 19 and 20 are both the same thing. I'll tell you up front, the answer is the slope. The slope of this equation is 4. The slope of this equation is negative 4. Those are the answers. How we find those answers, how we prove we know those answers, is by doing the difference quotient, which is to take this equation, 4 times something minus 15, and instead of putting an x there, I'm going to put x plus h. Okay, so x plus h. Then I'm supposed to subtract the original equation. So I have to use parentheses here, 4x minus 15. So you can see I put an x plus h in for x, and then I'm subtracting the original problem, all of it divided by h. That's what the formula tells me to do. If I distribute, I get 4x plus 4h minus 15 minus 4x plus 15 all over h. You notice that the 4x and negative 4x should cancel. The negative 15 and positive 15 should cancel, leaving me with 4h over h, which is 4. Now, as long as it's a linear problem, a line, the answer will be the slope. I'm going to leave you at number 19 to do yourself, but you should come out as negative 4. These next three questions are all about 20, and it's just about understanding the shifting that takes place. Here this says x plus 2 and then a minus 1. Okay, because the plus 2 is with the x, that means I'm going to do the opposite, which is left 2. I'm going to move that dot left 2, and it says minus 1. I believe, or was that plus 1? Let me look a little closer at the actual answer key. It looks like it is actually a plus 1. You can't see it in the print. If you did negative 1 because of how it printed, I'd understand, but we're going to go ahead with this plus 1. So that means up 1. We can tell it's not changing signs because it wasn't grouped with an x. Then I just follow the slope here on the right, follow the slope here on the left, and there's my new graph. On these other questions, it's pretty much the same idea, but we look at this ordered pair. This is x plus 4, right here, x plus 4 in the exponent, and minus 2. That would tell me to go the opposite because it's with an x. So we're going to say 4 left and 2 down. This one here is x minus 1, and plus 3. And so this tells me to go right 1 and up 3. So if you just move the dots that way, it should create the same graph. Alright. 21, we're supposed to find the inverse. Remember that this is really a y equals, and so to find the inverse, we're going to switch x and y, meaning that we'll have x equals 2y minus 3. To find its inverse, I just need to solve for y, so I'm going to add 3 to get x plus 3 equals 2y, and to finish, we divide by 2. Now, if we write f to the negative 1 of x, that's the name for inverse. Technically, I'd take a y as well, but this is the format we traditionally would use. We can have x plus 3 all over 2, or you could have 1/2 x plus 3/2. Either one of those choices is definitely acceptable. It's just a matter of which preference do you have. Now we're going to find the vertex. Okay, if I wanted to find the vertex, traditionally what we do is we say x equals negative b over 2a. Well, b is our negative 56, so this would be 56 over 2 times a, which is 2, which is 56 over 4, which turns out to be 14. Now, at this point, that's the x value. To find the y, I have to plug that x into the original equation. If I do, it's going to spit out negative 379. So my vertex is 14 comma negative 379. Now I know some of you are going to want to use your calculator, so kind of watch the calculator over here. We're going to go through and do that. We have 2x squared minus 56x plus 13. If we graph this, we're not going to see much. See, we see this very vertical part here. This graph is way outside of my viewing window. So you kind of have to change your viewing window to fit it. I'm going to first start with zoom, and whoops, I should have gone the other way. Zoom fit. Okay, so I can see part of it, but I can tell it's over here on the right. So I'm going to change my window a little bit. It's definitely negative. Now when I go to my window, I notice it's going from negative 10 to 10. I don't even need the negatives. I know it's on the right, so I'm going to go from 0 to, and I just need a big enough number to make it work, so I'm probably going to go to 20. Counting by ones, that's fine. But the y values, I need this to get really negative. I didn't seem to feel like I saw the bottom, so I'm going to go like negative 500. But the top, it could be 0, and then count by, say, 50 or something like that. We can do a lot of different adjusting if we still can't find the bottom. But right here I feel like I found it. So now I can do a second trace, which is a calculation. I want the minimum. To do this, you have to press enter on the left side of the minimum, and then you have to arrow over until you've crossed it and hit the right side of the minimum. And now when it searches, I get 14, negative 379. So that's a way we could use the calculator to do the same thing. Here we have x minus 2i and x plus 3i. X times x is x squared. X times 3i is 3xi. Negative 2i times x is negative 2xi. And negative 2i times 3i is negative 6i squared. So I've got x squared. If I combine my xi terms, that should give me plus 1xi. And then this 6i squared. An I squared, remember, is a -1. And a -1 times a -6 is a +6. Okay? Now we're going to sketch a graph of y cubed, -y cubed minus 3. Now, a couple things to keep in mind. The original graph of y equals x cubed looks like this. This is y equals x cubed. What we're really asking you to do is shift it down 3 and flip it upside down. So I'm going to take this dot right there, go down 1, 2, 3. There's the dot, and instead of graphing it so it follows the same pattern, I'm going to graph it backwards or upside down. So this would be y equals -x cubed minus 3. You could graph it in the calculator and try to model it that way too, but I feel like that's just as good as anything. If you understand how end behavior works, which way the arrow should point, you should be okay there. The next thing we're going to look for are vertical and horizontal asymptotes. Horizontal asymptotes are either bottom heavy or balanced. Balanced would be like x over x or x squared over x squared, and then you would use the leading coefficient. So if this equation was 2x over x plus 1, because they're both x to the first, I would use the leading coefficient test, which would be 2 over 1 or 2. But that's not the case in this problem. This is a bottom heavy because we have more x's on bottom than we do on top. All bottom heavy ones have a horizontal asymptote of 0. So if we're looking for horizontal, it's 0. Now vertical asymptotes always come from the denominator being equal to 0. So I have x plus 1. I want to know when does it equal 0. The answer would be when x is -1, would be my vertical asymptote. These next two 26 questions, they're basically identical. I'm just going to do the first one and then you guys can do the other. We're compounding continuously, so they give us a formula. And it says, how long will it take $6,000 to double? Well, you have to know what that means. It means that the amount in the account we want is $12,000. The amount we put in the account was $6,000. E to the rate 0.062t. To solve this, first thing we're going to do is get rid of this 6,000 by division. So now we got 2 equals e to the 0.062t. This is a logarithmic problem. So remember that b to the x equals y is interchangeable with log base b of y equals x. Now because this is a base e, we can use the ln button because that's automatically base e of the other side of the equal sign always equals the exponent 0.062t. So I'm going to take the ln of 2 in my calculator and then I'm going to divide that by 0.062. And that gives me a time of approximately 11.2 years. If you do the same thing on the other question 26, you should get 19.8 years. Okay, number 27 down here, find the exact solution. That of ln of 3x minus ln of x minus 1 equals ln of 4. I do not like this subtraction right here. I am going to move this over to make my life easier. So this is ln of 3x equals ln of 4 plus ln of x minus 1. The reason I like doing that is addition becomes multiplication inside the logarithm. So I have the ln of 3x equals the ln of 4x minus 4 because I get to multiply that in. Now that there are two ln's equal to each other, I can cancel the ln's and have 3x equals 4x minus 4. I'm just going to minus 4x and get that negative x equals negative 4. Therefore, x equals positive 4. Alright, we're down to the last few. In both of these two questions, when we're solving these systems, we're really just doing a substitution of some type. I really like this first example. What I'm going to do is I'm going to take this 2x minus 7, and I'm going to plug it in for the other y because they're both equal to y. So 2x minus 7 will now equal x squared minus 2x minus 3. And if I minus 2x and add 7, minus 2x and add 7, you get 0 equals x squared minus 4x plus 4. If I factor that, I'm going to get x and x, minus 2 minus 2. So the only answer for x is 2. Now down here, I think you end up with a couple of different x values out of this equation. You should end up with x equals 4 and negative 1 when you do it down below. Now that I've got that 2, I'm just going to literally plug it in right there. 2 times 2 is 4 minus 3. Y would equal negative 3. So my answer is 2, negative 3. Go through the same process down here, factor and solve, and you'll get the x is 4, negative 1. Plugging those back in, you get that 4 produces a 29 for a y value, and negative 1 produces a 4 for a y value. End up with those two answers. Question number 29 is actually the same as one of the earlier questions, but I bring in this x is greater than or equal to 3. The reason I bring that in is just so you can get used to graphing vertical and horizontal lines. So if we remember from earlier in the first one, this becomes 3x minus 2 is less than or equal to y. And this one, when I bring the x over, becomes y is greater than negative x. And I think that's a dotted line. Alright, so the 3x minus 2, I'm going to come down 2, and then I'm going to end up with a line that does something like this. That's that line, and then I have a dotted line that comes through like this. That's that line. Both of them want a shade above, so I'm up in this region. And then comes x is greater than or equal to 3. So I come out to 3 on the x-axis, and I draw a vertical line like that. It says greater than, which means to shade this way, so I end up with just this region there as my final region. Okay, so what we're going to do here with, let me get this pulled back up. Okay, what we're going to do with this last question, we need to do this binomial expansion theorem, which means we're using Pascal's triangle. So over here on this side, I'm going to write out Pascal's triangle, which starts 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. I know I have to go until I get to this 5 exponent, which is 1, 5, 10, 10, 5, 1. So this is my line of numbers that I'm going to use to be able to do this expansion. It starts with 1, parentheses, x, parentheses, negative 2y, plus 5, parentheses, x, parentheses, negative 2y, plus 10, parentheses, x, parentheses, negative 2y, plus 10, parentheses, x, parentheses, negative 2y, and I keep going like this until I have finished the whole sequence. It's really important that you include that negative with the 2y because this is a minus problem. If it was a plus, you wouldn't need to include the sign. We're going to go 5 and 0, 4, 1, 3, 2, 2, 3. You can see the x is dropping and the y is growing in exponent. 1, 4, 0, 5. Anything to the 0 is out of the problem. So my first term is just 1 times x to the 5th, which would be x to the 5th. Now in the next problem, it's really important that we go through 5 times negative 2 to the 1st. You can definitely use your calculator to help with that. If you're struggling with it at all, it's 5 times, and we're going to use parentheses here, negative 2 raised to the 1st. It turns out to be negative 10, so it's minus 10, x to the 4th, y to the 1st. The next one, it would be 10, parentheses, negative 2 raised to the 2nd. Okay, and we end up with 40. That's positive, so plus 40, x cubed, y squared. You'll notice that it goes back and forth with the negative. If I do the same thing with this 10 here, 10, negative 2 to the 3rd, that's negative 8 times 10 is negative 80 x squared, y cubed. Keep moving down. 5 times negative 2 to the 4th. Negative 2 to the 4th is 16 times 5 is 80, but that's positive 80 x, y to the 4th. And then this last one, 1 times negative 2 to the 5th is negative 32 y to the 5th. And that is how we do the binomial expansion. The alternative is to write out x minus 2y 5 times and just FOIL one at a time until you're all the way done. Alright, that's it.